Alright, so today's video is going to be about rate of change. Our objective is to be able to identify the rate of change or the slope in real world situations. Alright, so first talk about what constant rate of change means. Alright, constant rate of change is the ratio of the input, which is x, and the output, and those have to remain at a constant proportion. So it's just like the constant of proportionality that we talked about yesterday in class. Whereas if you had x and y values, right, and then you put them in k equals y over x, right, you have 1 over 2, 2 over 4, 3 over 6, where they would all equal the same thing, so the ratio stays constant, and so that will be a constant rate of change if you're looking at it on the table. Alright, so moving on, next vocabulary word is what's called discrete data. Discrete data can only contain certain values. So example of that is if you're counting students in a classroom, right? You can only count in whole numbers because either you have a whole student there or you don't. You can't have half a student or 1/10 of a student or anything like that. So discrete data can only have certain values. And in this situation, you would only be able to have whole numbers. If you're looking at continuous data, you can have any value. All right, so you're not limited to whole numbers or integers or anything like that. It could be literally any value. So if you're looking at an example like pounds of sand, if you're talking about pounds of sand, well, you can have a whole pound, you can have 10 pounds of sand, you can have 10.2 pounds of sand, 10.5, right? There's a lot of different ways you can, have different pounds of sand and measure that, and you're not only held to, certain numbers. So we will be distinguishing between discrete and continuous data in these as well. Alright, so we're looking at a graph here. Several questions that we're going to go through. First, I'm going to describe the graph. And when you describe the graph, basically you're just looking at your axes to get an understanding of what the graph is talking about. So my y-axis is talking about number of chairs, and the x-axis is talking about number of round tables. So this graph to me is just describing, chairs per table. Okay, and so now we talk about the rate of change. What is the rate of change or slope of the line? So since rate of change is another word for slope, we would calculate it the same way we do slope. So if I'm looking at this line, if I want to calculate the slope, I can do it one of two ways. I can use a slope formula, y2 minus y1, or x2 minus x1, or you can just count rise over run and do it that way. I'm going to count rise over run because it's a little bit simpler. Alright, so I know that the first point starts at 0, 0, and I'm going to go to this point here. So if I rise 10, so I went up 10 from 0 to 10, and then I run 1, 2. My rise over run will be 10 over 2, so the rate of change here will be 5 over 1. So that is the slope or the rate of change here, 5 over 1 or 5. But what does that mean, right? So what does the slope represent? Well, my y-axis is chairs, and my x-axis is tables. So it's 5 over 1 chairs to tables. So to me, this means that the slope represents that for every one table there are 5 chairs, or there are 5 chairs per table. Okay? And so is this data continuous or discrete? I would say this information is discrete because you're not going to count half a chair or have half a table or a piece of a table. It's either going to be a whole chair or a whole table, and that's how you would count these. So I'm going to go with discrete. And that's essentially it. The next example, here I have two lines, two lines on my graph. So I'm going to describe the graph. Again, I'm going to look at my axes and see what it determines. So I have dollars earned and then time and hours. So this graph is talking about money per hour, or dollars earned per hour. Okay. So what is the rate of change or the slope of each person's line? So I'm going to get a slope for Kel and also get a slope for Mariko. Okay. So looking at Kel first. All right, this is Kel's line. To get the slope here, I'm going to count rise over run. So I start at 0, 0, and I rise up to 8.4, and I run to 1. So 8.4 over 1. And then for Mariko, this is the line for Mariko, and I would rise to 7 and over 1. So 7 over 1. So in each case, we see that the y-axis represents dollars and the x-axis is hours. So for Kel, that means that this person earns $8.40 per hour. Okay, and then for Mariko, I'm kind of running out of room, so I'm going to put it on the side. For Mariko, this person would earn $7 per hour. All right, and there you go. So if you add another person in there named Jim, if Jim earns $7.50 an hour, I'm going to hit a little dotted line and sketch where his line would be. So if Jim earns $7.50 an hour, in 1 hour, Jim would earn $7.50, which would be about right here. So I'm going to sketch a little dotted line to give me that. All right. And that would be Jim's line here. Because it's $7.50, almost to $8, but not quite. All right. And so would this data be continuous or discrete? I would say that this data is continuous because you're not limited to only, counting by hours. It doesn't have to be just 1 hour or 2 hours, right? You could work 1.5 hours or 2.5 hours or 1 hour and 10 minutes, right? So there's a lot of different intervals that you can have in there and still, get that data. You don't have to, you're not limited to 1 hour, 2 hours, 3 hours, or $1, $2, $3. You can get, $15.10 if that's the amount of time that you work. So I would say this is continuous. All right. And so here is a U-try. Make sure you describe the graph, tell me what the slope is, answer all the questions. We will discuss tomorrow.